And anytime the inside function is a line, y equals mx plus b, or ax plus b, if you did a chain rule, can you see that you would have to multiply by just a? So here's some derivatives, right? And we did these when we first learned the chain rule. What's the derivative? Bring the 7 out in front, subtract 1 from the exponent. Because of the chain rule, you'd have to multiply by 5. So anytime you had this, ax plus b inside in a derivative, because of the chain rule, you'd have to multiply by the derivative of the inside, which would be multiplying by a. What if you have ax plus b inside of a natural log? If you did the derivative, you would have 1 over 4x plus 7. And then because of the chain rule, you'd have to multiply by 4. So anything of the form ax plus b inside of a derivative, inside a logarithm, when you do the derivative, you'd have 1 over that, but then you would have to multiply by a. What about e to the x? Well, e to the x would stay the same, but then because of the chain rule, you'd have to multiply by the derivative of the inside function, so you'd multiply by 10. And if you just had it general as ax plus b inside of e to the x, you would have to multiply by a. Are you noticing a pattern? Okay? If you have ax plus b inside of sine, if you did the derivative of your outside function, keep the inside the same, and then you'd have to multiply by 2. So if you had anything inside, it'd be the derivative of the outside function, you'd keep the ax plus b, and you'd have to multiply by a. And one more. If you had to do the derivative of cos is negative sine. Keep the inside the same, and then have to multiply by the outside function. Then you have to multiply by the derivative of the inside function. And so we have this pattern that if you have anything inside of a function that is in the form of a line, ax plus b, that involves a chain rule, that has you multiply again by a, can you see that if you're doing the integral and working backwards, if all of these ones have a multiply by a at the end, you'd have to undo that. So all of your integrals of the form ax plus b, you're going to need to divide by a. We can do an example right beside, well, we have examples afterwards, but maybe we do an example right beside. Let's say you have 3x plus 7 to the 5, and you want to find the integral. You've got a line inside of a power. So if you did your power rule would say, I need to add 1 to my exponent and divide by my new exponent. But because there would be a chain rule if I did the derivative, which means I'd also have to times by 3, to undo it, I'd also have to divide by 3. So we have the n plus 1 on the bottom is from the new exponent. The a on the bottom is because of the chain rule would normally multiply when you do the derivative, so we need to divide when we do the integral. And once again, whenever you get your final answer, oh, I almost forgot, plus c. Whenever you do your integral, you can always afterwards take the derivative. Can you see when you take the derivative, the 6 would come out in front, nicely cancel out with this 6. You'd subtract 1 from the exponent and get the 5, which is what we wanted. Then you'd have to do the chain rule and say the derivative of the inside would multiply by 3, which would nicely cancel out with the 3 on this bottom, leaving you just with this equation in the end. Here's another one. So we want to find the integral of the cube root of 5x minus 4. Step 1, change the cube root to a 1/3. And we notice what's inside the 1/3 is 5x minus 4. It's in the form ax plus b. So when we're integrating, we can add 1 to the exponent and divide. But because of the chain rule would also have a multiply by 5, we also have to divide by 5. Simplifying this, and I should have, I'm not going to take off marks if you don't put the plus c until the very end. Technically, you should have the plus c there and the plus c in the end as well. Try the next one on your own. All right, let's see how you did. No problems? Okay. And so the same thing's going to happen with natural log and e to the x and sine and cos. So I think you are ready to try the next 4. Again, I'll put up the answers to each of them as we go. So again, you do the derivatives as per normal, but then you also have to divide by a because you're undoing the chain rule. Here, I'll put up the answer to the first one. How'd you do? Good? How are you guys doing? Are you ready for this one or not yet? Yes, yes, yes. Alan? Okay. Oh, I tried to do so. Oh, there we go. Got fancy. So again, when you're studying these questions, look at the wording because I tried to word them all a little bit different just to get used to different ways of asking the same thing. So this last one, right, integrate with respect to x. Oops. So pretty. So I really encourage you, there's questions at the bottom of this. I know there's been questions at other parts already, but if you start with these questions here, they start to incorporate more of the chain rule and having to divide by it. Get some practice with your integrals because it'll, right? The practice you did with your derivatives is going to come in handy here because the more you practice your derivatives, the easier it is going to be to recognize what to do with the integrals.